Now let's study about potential energy. Okay. So now I have this chalk. Okay, I keep it here. Let this to be the ground. Now what I do is I do some work. I give some force here and lift this chalk upwards. Okay. So at this position we'll have some energy. That energy we call it as potential energy. So potential energy is energy possessed by an object by virtue of its position. Okay. So let's see this is a diagram here now. So let this be the ground. Okay. Now I have the chalk here. Let the chalk be at this point here. Okay. I will raise the chalk upwards. So this ground point, okay, ground we can mark it as O, and this point you mark it as P. So we will lift it up to a particular height here. Okay. We moved upwards. The height you write as H. Okay. So this we say it as potential energy. Okay. At this point we consider potential energy to be 0. At this point P it has some potential energy. So let's see what's the formula for that. Okay. Potential energy symbol is we write as U is equal to, it's the work done to move the object from one place to next place. So work done formula we know, that's force into displacement. So force the vector quantity, so F vector into or dot dr vector. Okay, F vector dot dr vector. So this is the formula for potential energy. Now let's go to the definition now. It is defined as the amount of work done by an external force in moving an object at a constant velocity from point O, the initial location, to the point P, final location. At the initial point O, potential energy can be taken as 0. So let's see this. It's defined as the amount of work done to move an object from one place to next place. So constant velocity, we see that point O to point P. Okay, so point O is the initial position, down, ground, and point P is the higher position, upwards. Okay. At the initial point O, we can say that the energy is taken as 0. Okay. So this is a formula for potential energy. Now, what we do is we take different types of potential energy. There are different types of potential energies there. Let's see what are each types now. Let me erase the board here. Let us now see the different types of potential energies. Okay, there are 3 types of potential energies. We'll take as an example here. There may be many types. We'll just take only 3 types. The first type we see there's a gravitational potential energy. Okay. First type we see it as gravitational potential energy. Yeah, write short form as potential energy is PE. So this we saw. We move the chalk from one place to another place here. Okay. So like this way, chalk was first down. Now you raise to a particular point here upwards. So in this type, okay, or in this condition, the chalk has a gravitational potential energy here. The potential energy is due to gravity. Okay, we're doing some work against gravity. Okay, that's the first type here. Now let's see second type here, that is elastic potential energy. The second type we mark it as or write it as elastic potential energy. Okay. So elastic potential energy, what is it? So if you take a rubber band or spring, okay, we take a spring here, we can stretch a spring or compress a spring and leave it will again come back to its original position. So that time when you compress in the spring, okay, the energy stored is stored as potential energy. So we have a spring here. This is spring. Okay. When you compress a spring, what happens? The energy is stored here, or when you expand it, the energy is stored as potential energy. Okay, it's useful in many devices. In bike we have shock absorber, car we have shock absorbers. Okay, in watches there are springs there. They store the potential energy. So that kind of energy we say is elastic potential energy. Let's see third example for potential energy. Okay, that says electrostatic potential energy. Electrostatic potential energy. So what do you mean by electrostatic potential energy? So now we have 2 charges here. Okay, we remember if you rub an object, it will get charged up. Okay, so when you similarly comb the hair, the comb will get charged. Okay, it can attract piece of paper. So there are 2 types of charges. One type we say is positive charge, another type is negative charge. Okay, so positive and negative, between that there will be an attraction force there. That we say is that energy stored as electrostatic potential energy. Okay, so these are 3 examples for potential energy types. Okay, now we go to again the chalk example. Okay, I move the chalk upwards from the ground. Okay, so this is the ground here. The chalk is moved upwards. The chalk has a mass m. Okay, and we move to a particular height h. In this case, okay, a very important expression for potential energy U is equal to mgh. Okay, this formula is used here. Here U stands for the potential energy. Potential energy, remember the symbol for potential energy is U. Okay, we don't write simply PE now. Okay, write short form. So U stands for potential energy. M is the mass. G is what? G is the acceleration due to gravity. Okay. The acceleration due to gravity. And H is the height. The height above the ground. So G value, that is how much is the value of G. G is equal to usually 9.8 meter per second squared. So this is a formula for potential energy. Okay. So this we use it generally. Okay, while doing sums. Remember for kinetic energy we had half mv square. Same way the formula for potential energy will be U is equal to mgh. Okay, this formula you must remember. We will be using it in later classes there. Okay, thank you for watching.